Lesson 7-3, Ellipses and Circles. An ellipse is the set of all points in a plane where the sum of the distances to the two fixed points called foci is constant. So that's a focus and that's a focus. So the red lines, if you add the lengths of the two red lines together, they will be the same no matter where the point is on the ellipse. We have a major axis. A major axis goes the longest distance. So it's the longest segment across the ellipse, and it connects two vertices. So that's a vertex, and that's a vertex. Minor axis, the shortest distance, and it connects two covertices. That's a covertex, and that is a covertex. And of course we have the center. A circle is a special form of an ellipse where both the foci are at the center. A horizontal ellipse. The major axis is horizontal. The center is HK. The major axis length is 2a. So from the center all the way to the vertex is a. The minor axis length is 2b, so the center to a covertex is b. And the center to a focus is c. Those are all related with c squared equals a squared minus b squared. And you see you have expressions for the vertices, which are taking your center and adding or subtracting the distance a from the x component. Covertices are taking the center and adding or subtracting the distance b from the y component. And the foci, taking the center and adding or subtracting the distance c from the x component. And you see in yellow the standard equation of a horizontal ellipse. If it's vertical, now the a is going up and down and the b is going sideways. So the vertices, covertices, and foci get switched around a little bit. For a horizontal ellipse, the major axis is horizontal. The center is HK. The horizontal axis length is 2a, so from the center to a vertex is 1a. Vertical minor axis length is 2b, so from the center to a covertex is 1b. And for a focus, the distance from the center to a focus is c. Those are related by c squared equals a squared minus b squared. To get the vertex, you start at the center and you add or subtract a to the x coordinate. For the covertex, you start at the center and you add b or subtract b to the y coordinate. And for the focus, you start at the center and add or subtract c to the x coordinate. And you can see in yellow the equation of a standard horizontal ellipse. If we make it vertical, the x and h kind of change a little bit, but it's the a, the b, and the c have flipped. So the vertices, instead of being the a being in the x, now we're adding it to the y. Covertices, instead of b being in the y, we're putting it in the x, and so on. And in the equation, the x minus h traded places with the y minus k. In both cases, a is bigger than b. So to know whether it's horizontal or vertical, the bigger number is on the bottom. So you look at the two denominators. Whatever letter that's under, X or Y, tells you whether it's horizontal or vertical. X is horizontal, Y is vertical. Like we said, A is the distance from the center to the vertex, B is the distance from the center to the covertex, and C is the distance from the center to the focus. Here's the equation for an ellipse. Let's find the center, vertices, and foci. Now this is not standard because it doesn't equal 1. So let's divide by 36 so we can make it equal 1. So 9 over 36 is 1/4. So I can make it x squared over 4. 4 over 36 is 1/9. So make it y squared over 9 equals 1. Now also remember, the largest denominator needs to come first. So the y squared over 9 needs to come first. So the y squared comes first. We compare this to y minus k squared over a squared plus x minus h squared over b squared equals 1. From that we can see that h equals 0 and k equals 0, since there's nothing being subtracted. We know that a squared is 9, so a is 3, and b squared is 4, so b is 2. And we can also find c. c squared is a squared minus b squared. A squared was 9, b squared was 4. So c squared is 5. So c is the square root of 5. So our center is hk, which in this case will be 0, 0. The vertices. Let's see, the y comes first. So that means it's moving in the y, so it is a vertical ellipse. So that would be h, and then k plus or minus a. So that would be 0, 0 plus or minus 3, or 0 plus and minus 3. So that would be 0, 3, and 0, negative 3. And then the foci are h, k plus and minus c, or 0, 0 plus and minus the square root of 5, or 0 plus and minus the square root of 5, which would be 0 square root of 5 and 0 negative square root of 5. So you have 2 of them. Let's find the standard form of an ellipse centered at 1, 2, so I can put my center. A major axis length of 10. So if the major axis length is 10, that means the vertices are 5 spaces away. So that's telling me that A is 5. The foci are negative 2, 2, and 4, 2. And so the major axis goes through the center and the foci. So if A is 5, I can count 5 spaces away, and that would be a vertex away from the center. So that distance is A. Well, we also know C. This distance is C. C is 3. And so we could find B by C squared equals A squared minus B squared. So it looks like B is going to be 4. All right, this is horizontal because the major axis is horizontal. It has to go through the center and the foci. If we want to put B on the graph from the center, we go up 4. That gets me a covertex. Go down 4. That gets me a covertex. This is how you graph. You plot the center, and then you plot the vertices, which is the distance A, and then the covertices, which is the distance B from the center. Since it's horizontal, it's x minus h squared over a squared plus y minus k squared for b squared equals 1. So it'll be x minus 0 squared over 5 squared and y minus 0 squared over 4 squared, which gives us x squared over 25 plus y squared over 16 equals 1. And now to graph it, again, to graph it, plot the center. Plot the vertices by going the distance A from the center. If it's horizontal, horizontally. If it's vertically, vertically. And to get the covertices, go the distance B from the center. And then you just draw the nicest ellipse that you can through those points. And that's a sketch of the graph of the ellipse. Let's sketch the graph of this. Woo! We have both x squares and y squareds and x's and y's. We're going to have to complete the square in both x and y. So start by grouping the x's together, and then grouping the y's together. And let's put the 211 on the other side of the equal sign. So subtract 211. All right, next we need to factor, because completing the square only works when it's 1x squared or 1y squared. So let's factor the x's. And let's factor the y's. So for the x, I factored out 25. For the y, I factored out 9. And now we complete the square. You complete the square by adding half of the middle number squared. So half of the middle number squared. But you have to do that to both sides. But wait, that's not all. We have this 25 out here, which means there's 25 of these parentheses. So I've actually added that 8 over 2 squared 25 times. So on the right side, I need to do it 25 times. And for the y, there's 9 of the y groups, which means there's 9 of these 4 over 2 squareds. So I need to add 9 of them to the right side. All right, we can now factor, write them as perfect squares. So it'll be x minus, that's 4 squared, right? So be 4. Be y plus 4 over 2 would be 2 squared. And when you combine all that stuff on the right side, we get 225. Well, let's get in standard form, so let's divide everything by 225. 25 over 225 reduces to 1 over 9. And 9 over 25 for the y's reduces to 1 over 25. Oh, but we need to put it in order, so the one with the highest denominator goes first. All right, so what's this tell us? This tells us it is vertical because the y comes first. We know the center is, remember this is h and this is k, it's backwards. The center is 4, -2. This is a squared, so I know a is 5. This is b squared, so I know b is 3. And that's really all the information I need to graph. So to graph, plot the center at 4, -2. I count, since it's vertical, up a, so it's 5, 1, 2, 3, 4, 5, and down 5 from the center. It's the vertices. And sideways then the distance b, which was 3, to get the covertices. And then you draw your best ellipse to go through your vertices and covertices. Eccentricity is a measure of how circular the ellipse is. And it's calculated c divided by a, so the distance to the focus divided by the distance to the vertex. And for an ellipse, it's between 0 and 1. If the eccentricity is about 0, then the ellipse is almost a circle. If e is close to 1, then the ellipse is almost a line.